when you will come next time, you will do one part, this part only, solubility. After that, when you will come, you will do this part, the functional group. So, the experiment is in two parts. You will do one by one, but I will do it all together today. So, you look carefully. If you have any questions, any doubt, anything you don't understand, you can ask me. Okay? But next time when you will come, nobody will talk with each other. Because this is not from my side. This is not from my side. This is from the university, that during the exam, nobody should talk. What he is doing? What are you doing? It's about the solubility. Solubility gives us a lot of information. For example, if we dissolve something in water, you know water is polar.
Yeah.
Anything which will dissolve in water, that will be polar. And anything which will not dissolve, that is non-polar. Right?
Yes.
So, we will check the polarity in the water. Then we will check the polarity in sodium hydroxide. Sodium hydroxide is a base. You know what is acid and base?
Yes.
Acid which give protons are hydrogen ion, and base which accept proton. Okay? So sodium hydroxide is a base. Any base which dissolve in water is called alkali. So this is an alkali. It has two names, base and alkali. Because it can accept the proton, it is a base. It can dissolve in, it is soluble in water, so it's an alkali. So now if anything dissolves in the base, that will be acidic. Any substance which dissolves in the base is opposite. Opposite of the base is acid. So that will be acidic or phenolic. For example, this is carboxylic acid. Look over here. It will dissolve in the base. And this is phenol. And phenol are also acidic. There is a OH group, but they are very, very weak acid. So this and this both will dissolve in the base, in sodium hydroxide. Did you understand? Anything which dissolves in the base will be either acid, carboxylic acid, or it will be phenol, phenolic. One of them. Phenols are very weak acidic, and this is a strong acid. Now, to check this one, which is weak and which is strong, we do another test with the sodium hydrogen carbonate. When we do the test with sodium hydrogen carbonate, this is the best reagent to check about the acid. If you want to see something is acidic, you always use sodium hydrogen carbonate. Not only organic, also the inorganic acids like hydrochloric acid, sulfuric acid, nitric acid, inorganic acid, and also the organic acid. If you do the test with sodium hydrogen carbonate, you will see the effervescence, carbon dioxide will be going out. So which means this is an acid. Did you understand? So if someone asks you what is the test of an acid, always tell him do the reaction with sodium hydrogen carbonate. When you say an acid donates proton, that is a definition. That is not a test. The test is it reacts with sodium hydrogen carbonate and carbon dioxide is given out. So if no carbon dioxide is given out, it's not acid.
Space.
Could be any other thing. We will not write base. We will not write its base. Could be anything. We will say not acid. Did you understand? Then I will check the solubility in hydrochloric acid. This is an acid. Any substance which will dissolve in acid, it will be basic. And any substance which does not dissolve is not basic. We will not say acidic. We will not say something else. Any substance which dissolves is basic, and substance which does not dissolve, not basic. So I will show you these tests today. there are so many solvents, big list of the solvents. Because you are doing it first time, you never did it before, so I have selected few of the solvents like water, like sodium hydroxide, sodium hydrogen carbonate and HCl, only few. So to give you an introduction, to tell you that the solubility, it gives us very useful information. So that is the purpose of this experiment, so you can understand about the nature of the organic compound, that whether they are polar, they are acidic, or they are strongly acid, or they are basic. This information you will get from this part. I will show you how to do the test. And next time when you will come, you do the test by yourself exactly in the same way as I am doing it. For example, I will start with water. And I will take acetone. Acetone is a ketone. You know that. You have studied organic. Acetone is a ketone, and ketone, they are polar compound. You know it. If I take some acetone in the test tube and I add into it some water, and you can see that it dissolves. Acetone dissolves in water, which means that acetone is polar. Very good. Which means acetone is polar. Then I will take benzoic acid. This is the benzoic acid. Here is the carboxylic acid. And here is the benzene ring. The carboxylic acid, COOH, it is polar. But the ring, benzene ring, is a big ring which is non-polar. The big ring does not dissolve in water. So, if I take benzoic acid, take small quantity as I am taking, take the small quantity, and I put some water in that, and you can see that it is insoluble, does not dissolve. You should not take large quantity. You know that sugar is soluble in water, sugar dissolves in water. Yes. If you take large amount of sugar and less water, it will not dissolve. So that's why you must be very careful about the quantities. Look how much quantity I am taking, very small, only few crystals. And then you add into it water and you see that it does not dissolve. So we will say it is non-polar. Now I will check with the sodium hydroxide. I just told you sodium hydroxide is a base, and this is also named as an alkali because it dissolves in water. I will take benzoic acid once again. I take small quantity of the benzoic acid, just little quantity of the benzoic acid, and I will dissolve it in sodium hydroxide, and you can see that it dissolves. Did you see that? It dissolves. Hold the test tube with 3 fingers. Hold it with 3 fingers from the neck and shake it. It will move like that. It will move like this. So look over here, it dissolves. Because it dissolves, it means that it could be acidic or phenolic. I told you earlier. So it could be acidic because the acid dissolves, and it could be phenolic. Phenol means benzene ring with OH is called phenol. So this hydrogen can be given. It can donate the hydrogen, but it's a very, very weak acid. Very weak acid. So anything which dissolves, let's suppose, now I know it is benzoic acid. Suppose I don't know what is that. Suppose I don't know and it dissolves. So what will be my answer? My answer will be that it could be acidic or phenolic. Now if I take a phenol, I have a phenol here, 2-naphthol. 2-naphthol is one of the phenol. So I take 2-naphthol, and this is the phenol. This is the phenol. And I put sodium hydroxide, and you can see that it will dissolve. 2-naphthol, because I told you the phenols are very, very weak acid. But still they are acid. It is weak, but they are acid. So that's why the phenol, it will dissolve. So answer is, if I don't know what is the thing, I will say acidic or phenolic. Did you understand? If I have something basic, the base will not dissolve in a base, right? So let's suppose I have paratroladine. Paratroladine, look, I'm taking very small quantity. Take care, regard about the quantity. When I am doing it, look how much quantity I am taking. Take little quantity. Now I take sodium hydroxide, and if I dissolve it, it will never dissolve, because paratroladine is a base. Base will not dissolve in a base. So we will say paratroladine, insoluble, not acidic or phenolic. Don't say, don't give any other name. Okay? So not acidic or phenolic, because it does not dissolve. Well, did you understand?
Yes, yes.
Okay, now to check that something is strong acid, like carboxylic acid, we take sodium hydrogen carbonate. I told you it's a very important reagent. If someone asks you what is the test of an acid, yes.
So base don't dissolve the base.
Yes.
Right? But we have something to study like dissolve
Like
dissolve
dissolve
like.
like.
Yeah, it means that this sentence usually comes for the polar things. Polar dissolve in polar and non-polar
Dissolve in
non-polar. For that purpose it is. When you are, it is now, this thing is very important for the sodium hydrogen carbonate. I want to tell you that, remember this thing, because you are going to deal with acid and base not only here, in the other labs also. If someone asks you what is an acid, how can you know it is an acid? Don't give any other test. Don't tell that it will do neutralization, because it will do neutralization, acid will do neutralization, but there is no observation. There are so many reactions acid can do, but there is no observation. So that is why the best thing is tell with the sodium hydrogen carbonate. If something is giving carbon dioxide bubbles of the sodium hydrogen with sodium hydrogen carbonate, that is an acid. Okay, so I take once again for this one benzoic acid. Here is the benzoic acid, and I add into it sodium hydrogen carbonate, and it will dissolve, and it is giving the carbon dioxide. Bubbles of carbon dioxide is formed. I want to show you, it is not in the list, I want to show you another acid which will give you more carbon dioxide. For example, acetic acid. You know acetic acid? Ethanoic acid? You know ethanoic acid?
Yeah.
Organic acid? So look over here, if I put sodium hydrogen carbonate, see this one.
What's this?
Bubbles, carbon dioxide. It means it's an acid. So benzoic acid also gave, but it didn't give you a lot of bubbles. It is not giving you a lot of bubble, because ethanoic acid is a stronger one. So if you get carbon dioxide over here, soluble with carbon dioxide, you will name it as strongly acidic. And if you are not getting carbon dioxide, so you can say weak acid or not acid. So if I show, for example, 2-naphthol, and you put into it sodium hydrogen carbonate, and you can see that no bubbles. No bubbles is produced, no carbon dioxide is produced. So you can say not acidic. Now, in hydrochloric acid,
So,
I have, yeah,
The bubble come means strong acid.
yes. Now we have the hydrochloric acid. Because this is an acid, anything dissolved in acid will be basic. Not dissolved in acid, not basic. So, if I take 2-naphthol and I add into it, for example, hydrochloric acid. I know phenols are acidic, so it will never dissolve. It will not dissolve. And if I take a base like petrolidine, petrolidine is a base. Petrolidine is a base, and I put into it hydrochloric acid, and look, dissolve. Because petrolidine is a base, so it dissolves in acid. So we will say it is basic. If something dissolves, we will say basic. Something not dissolved, not basic. Did you understand?
Yeah.
Yes. Doctor,
Yeah.
when I put naphthol with NaOH, what is the result?
It will dissolve. Naphthol,
Oh, okay.
and it will dissolve because it is acidic. Weakly acidic.
Two of them is acid.
Yeah, yes. Carboxylic acid is an acid. It gives hydrogen ion. It gives the hydrogen ion. Phenols are acid because they also give hydrogen ion, although very little hydrogen, very weak acid, but acid. Listen, boys. One thing I want to tell you. When you are here, so many students, they will take these reagents. So, when you are taking the reagent, there are 2-3 things you keep in your mind. These things are very, very important. Not only in chemistry, also in other labs. And since many of you from this college, they will go to, from this university, they will go to the other universities. And inshallah doing the research work and so much work you will be doing. Make sure when you take anything, first of all, you read it carefully what you are taking. Read the label. Carefully read the label. Point number 1. Second point, I have already told you, which is the most important point, never exchange the dropper. Never exchange. Because that is not a mistake, that is a blunder. Very big blunder in it. Consider, if a science student is exchanging the dropper. It's the biggest mistake. It's the biggest mistake. So make sure, why I am telling you, because when someone is taking from here, other is taking from here, there will be no dropper. There will be no dropper. So you don't put your dropper any place you want. Never, never. You remember from where you take the dropper and put it back on the same. Because many of them, they will contaminate. There will be a reaction. And it will contaminate, the whole thing will be damaged, spoiled. Which is considered as one of the biggest mistake. Okay? So when you are doing these things, make sure that you understand. Again, I am telling you one thing. I am not concerned with the result. You know me that I am giving the full grade, even the result is not good. But your technique should be excellent technique. Okay? So when I am doing, for example, look, you can hold the test tube like this. There is no problem. But not scientific way. Not scientific way. You must hold it in that way. If you hold, you can shake it, or you can shake it like this. But not scientific way. Not scientific way. You will hold it, move it, it will move like that. It will move like that. So it will dissolve easily, quickly. You see that one? So this is it. So from this part, which I have showed you, we get lot of information. Whether the substance is polar or non-polar. Whether the substance is acidic or phenolic. Whether the substance is a strong acid or not acidic. Whether the substance is basic or not basic. So we can do lot of more solvent. But as an introduction, just because you are doing it first time, as an introduction, only few solvents are being selected. When you will come next time, you will do only this part. You will copy it from here. I will not delete it. You will copy it from here. You can make the picture also. You will copy from here. I will tell you the page number next time. You copy from here and then you do the experiment. That's all. Experiment will be finished for you. When you will come next time, you will do this part, which I will explain you now. I will not explain again. I will explain this part which is about the functional group. Did you understand? You know that organic compounds, they are recognized by their functional group. Functional group is a very small part of the molecule. Sometimes it is only one atom, like O in ether. You know it?
Yes.
Like chlorine, only one atom. Sometimes two atoms, like OH. Sometimes three atoms, like aldehyde. Sometimes maybe maximum 4 atoms, like carboxylic acid. So it is a very small part of the organic compound. The molecule could be very big molecule. It will come on the board, one full big molecule. But the organic functional group is a small one, and this is responsible for the chemical properties. That is why it is very important. So I will show you some test of the functional group. The first functional group I am talking about is carboxylic acid. I just told you the best test of an acid is the sodium hydrogen carbonate. I told you that sodium hydrogen carbonate, this is the best test of an acid. Not only organic, all the inorganic also. So if for example, this is the same test which is over here. It is the same test. Once again I am doing with you. We take benzoic acid and then we add into it sodium hydrogen carbonate, and there are lot of bubbles are produced, carbon dioxide, effervescence. Effervescence means carbon dioxide produced. With lot of carbon dioxide bubbles are produced, which means that it's a carboxylic acid. Because we are doing the organic chemistry, today is the organic, that's why I am saying it carboxylic acid is present. Otherwise, in fact, all the inorganic acids, hydrochloric acid, sulfuric acid, nitric acid, what are they? Inorganic acid. They also give the same test. So since we are doing organic today, that's why I am writing carboxylic acid is present. Did you understand what I am saying? Otherwise, any acid, it will give carbon dioxide.
Can you repeat?
All acids, whether it is organic acid or inorganic acid, it will give bubbles with sodium hydrogen carbonate. With sodium hydrogen, if you have HCl, hydrochloric acid, it will give the bubbles. Is it hydrochloric acid organic or inorganic? Inorganic. It will give a test. Any acid, organic or inorganic, any acid will give the same test. But today what we are doing? Organic. So that's why I have written over here carboxylic acid is present. Because carboxylic acid is an acid, so it will give. And the 2-naphthol is a very weak acid. 2-naphthol is very, very weak acid, I told you. So if we put into it, no carbon dioxide is produced. So we will say, for example, today we will write it like that, carboxylic group is absent. Alright? Yes.
Evaluation mean
Effervescence mean bubbles, carbon dioxide. Bubbles. Effervescence mean bubbles. Effervescence mean bubbles. The next test is test of the hydroxy group, OH group. Hydroxy does not mean only alcohol. Alcohol have the hydroxy. Look over here, phenols. It is not an alcohol. Phenol is not an alcohol, but it has hydroxy. Look, benzyl alcohol, there is hydroxy. Look, ethanol for example, ROH, ethanol, methanol, there is hydroxy. Wherever there is a hydroxy group, OH group is present, we can do the test with cetic ammonium nitrate with this. We can do the test with this. I will show you. If I have ethanol, ethanol is having the OH. OH group is there in ethanol, ROH. If I put this one in ethanol, I will get the red color. See this one. Do you see? So if I get this information, red color, it means there is a hydroxy group. Alcohol has the OH group, so that's why the OH came. It is very important reagent. I tell you that, for example, in Europe and America, sometimes they check whether the driver is drunk. So if, especially when there is an accident, they check the driver. So they take this reagent in a test tube, and they ask the driver to blow into that. So that with a straw. So he blow, and if it become red, they catch him that you are drunk. The accident is because of that. So it's a very important test. Don't forget it. Okay? Then, if I take this one, benzyl alcohol. I have here benzyl alcohol, and because it's a benzene ring, does not dissolve in water, so I dissolve it in another solvent, 1,4-dioxane. This is another solvent. So I dissolve it in 1,4-dioxane, and I put into it silic ammonium nitrate. Look over here, there is red color, which means that there is a hydroxy group present. Did you understand? When I am putting something, boys, look over here. When I put something, I don't bring the dropper down. I don't bring down. Look over here. I am putting it from the top. And even I'm not touching it with the wall of the test tube. So when you do such type of experiment, make sure that you don't touch it with the test tube. Don't touch it. Do the practice. So you will see that the red color is there. Now, I will show you the test with the phenol. This is the phenol with the benzene with the OH. This is a dangerous compound. It's very corrosive. If you touch with your skin, the skin can be removed. So take care of this one, phenol. The other things, all these things, they are not as dangerous. They can make your skin like, look my fingers, yellow or orange. They can give you a color, but the color will go in 1 or 2 days. But this is dangerous. If you touch it with your skin, immediately wash it with the water and inform me. Because you know that the phenol, they are acidic. You know it. Phenol are acidic, I told you in the beginning. So we will wash the hand with a base to neutralize it. You understand? So if you touch, take care of this one. If you touch, wash it immediately and inform. I take the phenol, some phenol, because there is a benzene ring, it will not dissolve in water. I am dissolving in 1,4-dioxane. I dissolve it in this one, and I put silic ammonium nitrate, and I will get dark brown color. With few drops, I will get the dark brown color, which means that there is a hydroxy group. Did you understand? When I say hydroxy group is present there, then definitely many of you must be thinking, how can we know this hydroxy is an alcohol, or it is primary alcohol, secondary alcohol, tertiary alcohol? Have you read these things?
No, we didn't.
Primary, secondary, tertiary alcohol. Did you study in the class?
Yeah.
Okay. So while we have test to know that what is the test of the primary alcohol, what is the test of the secondary alcohol, tertiary alcohol. So we can differentiate. But I am not doing those tests because it's a fundamental lab. I'm just doing major tests. I am not doing those tests. Now the next test is for the carbonyl compound. What is carbonyl? Oh, carbonyl is a big family. It has 2 branches, aldehyde and ketone. Look, carbonyl is C double bond O is carbonyl. If one side is R and one side is H, aldehyde. And if both the sides are R, it's a ketone. So we have a reagent 2,4-dinitrophenylhydrazine for the carbonyl. One thing which is very important, you have noticed it, that if I am doing a test of the acid, I am using sodium hydrogen carbonate. if I am doing a test of the hydroxy group, I am using silicon ammonium nitrate. Now I am going to use 2,4-dinitrophenylhydrazine, which means that for every functional group there is a separate reagent. Separate. For carbonyl I am going to use another reagent. So different functional groups, they have different reagents. Special test. Every group has a special test. Do you understand? So if I take, for example, a ketone, you know that acetone is a ketone, a carbonyl. So I take only few drops, don't take too much, only 2-3 drops, don't take too much, and add into it 2,4-dinitrophenylhydrazine. This is the reagent for this one, and look over here. The orange precipitate, orange solid is formed. Did you notice? It means that it's a carbonyl. I know that this is acetone, but I took acetone. What is acetone? Ketone. And let's suppose I don't know what is this. It is in a bottle. I don't know what is this, and I get a test like that. What will be my answer? Maybe ketone, maybe aldehyde. Maybe ketone, maybe aldehyde. Today I know it, but if I give you the unknown, so the answer is maybe ketone, maybe, or we can say it's a carbonyl compound. It's a carbonyl compound. Okay? Now, if I take glucose, you know glucose? What is the formula?
C6.
C6H12 or
H12O6. With the first carbon of the glucose, there is an aldehyde. What is there? An aldehyde. So we can do this test. This is solid, and glucose is soluble in water. You know that. It is soluble in water, and if I add into it 2,4-dinitrophenylhydrazine, this one, I should get a test. I take this one and put over here, and this test will come, but it is slow. It's a slow reaction. So I can increase the rate of reaction if I put it in hot water. If I put it in the boiling water, the reaction will be fast. In 1 minute, I can get the orange precipitate. This reagent is for what? Carbonyl. If for example I have acid, carboxylic acid, will it work?
No.
No, it will not work. I can show you that it's acetic acid. Acetic acid means ethanoic acid. Ethanoic acid. So if I take the ethanoic acid and I put into it look, there is no reaction, and there will be no reaction, because this is not for the acid. Even if I heat it, there will be no reaction. Okay? Because one reagent for one family only. So this is the glucose. Look over here. It is giving you the orange precipitate because it is a carbonyl. It's a carbonyl. Aldehyde is there. So that's why it is giving a test. Did you see this note? Okay?
Okay.
And this one, which is the acid, it will not give a test. It will not give a test because 2,4-DNP is not for acid. Similarly, if you use the different reagent, it will not give. The next test is for the unsaturated compounds. What mean unsaturation?
It's not completely bound.
If there is a carbon-carbon double bond or carbon-carbon triple bond, alkene and alkyne,
Yeah.
it is unsaturated. Carbon-carbon double bond, not carbon and oxygen,
Yeah.
not carbon and nitrogen. carbon-carbon double bond.
Okay.
And if there is a carbon-carbon single bond,
Alkyl.
saturated. Okay. Do you know what is the test of the alkene? Have you read in the class?
Alkene, addition.
Addition reaction. The best, one of the best tests of the alkene is if you add bromine water. Bromine. You know what is the color of the bromine? Br2. Bromine is red brown. If you put in unsaturated compound in alkene or alkyne, it will become colorless. Red brown become colorless. But the bromine is very dangerous. It's a dangerous compound. It hurt our lungs. We should do this test in the hood, there at that hood. So I am not doing that test. I am doing another test of the bromine, which is with the KMnO4, potassium permanganate. I am doing with this one. It is purple in color, and with the unsaturated compound, the color will change. Change in color is called decolorization. When the color change, it is called decolorization. I will show you that. I have this alkene. I have an alkene, and I take the alkene. I take some alkene and dissolve it in alcohol. It is soluble in alcohol. And now I will add into it KMnO4, potassium permanganate. I will add into this 1 or 2 drops, which is purple in color, 1 or 2 drops, and you see that, look, the color changed from purple to brown. Did you see that?
Yes.
Which mean, change in color mean decolorization, which means it's an alkene. If I show you this, I take an alkane, look over here. I have an alkane. And this alkane, I add into it the KMnO4, which is purple in color. I put 1 or 2 drops, and you can see that there is no change in the color. It remains purple. Look over here. It remains purple. Do you see this one? See the difference.
Oh.
Look at. This is brown and this is purple. So if there is a decolorization take place, it means it's an unsaturated compound. So boys, today here in this part, I have shown you some tests of the functional groups. There are so many more tests, so many more. For example, how to check the primary alcohol, secondary alcohol, tertiary alcohol. If we have a carbonyl, how can we know this is aldehyde or it's a ketone? Then we do the Fehling solution, Benedict test, Tollens reagent, iodoform test. So many tests are more, which probably you will study later sometime. Today, as an introduction, I have shown you some of the tests. I hope you have understood this one. So the second time when you will come, you will do the test of this one. You will write all on the notebook, on the page, remove the paper, report sheet, and you will write all this next time when you will come. And you will do the test. Did you understand? First week you will come. The first week when you will come, you will do only this part. Solubility. Only solubility. You will write this information. This information is also written in the book, in your in your manual. It is written there. So if you write from there, or if you want to write from here, up to you. I will not erase it. I will not delete it. It is there. You can make a picture. You can take a photo.
Right now, sir.
Not now. Next time, when you will come, you will do this part only. You will not do this one. You will not do this one. After that, when you will come again, you will do this part. Did you understand?
Yeah.
Is the experiment is very well understood?
Yes.
Okay, nice.